there, kiddos, and welcome to your second video of the year. This one is over simplifying expressions, and just like yesterday, we have a couple vocabulary words that we need to go over. So that's the first thing we're going to do is talk vocab. And so a term is any number or expression or a combination of the two with multiplication or division that shows up in a problem. When you have multiple terms, they're separated with addition and subtraction, but a term itself is just a number, a variable, or the product of the two. So a number could be a term, 2, 8, 24. A variable, x, y, z, or it has to be the product of the two. So 2a, x times y, anything to that effect. That makes a term. Like terms are terms that have the same variable to the same power. So they share an exponent. And we'll talk about that in just a second. So let's talk about what are like terms and what are not like terms. Like terms, for example, 2a, 5a, 8a. Those are all like terms because they have a number and they have a letter and the variables are the same, a, and a. Things that are not like terms, like 2a and 5b, or even 18c, those would all be unlike because their variables don't match. And so another example, you can have multiple variables in a term, like xy. So I have 4xy, 0.05xy. I could also have 1/4 xy. Those are all like terms because their variable parts are identical, xy, xy, xy. Things that wouldn't be alike would be like 4xy and then just a y, because while they both have y's, since they don't both have x's, they can't be like terms. So another example would be like 3x. That also wouldn't be a like term with those because it only has the x part and not the y part. It has to have both an x and a y to be considered a like term. Now here's where the power or the exponent comes in. To be like terms, the z's, both of these have to have a z, but they also have to be z to the 4th power, because the exponents count as part of what we look at to see if they are the same. A z squared and a z to the 3rd power aren't the same thing. They mean two different things. So the exponents must also be the same. So z to the 4th and negative 2z to the 4th would be like terms, as would 10z to the 4th. But 3z to the 4th and 3z to the 3rd are not like terms because their exponents don't match. This 4 and this 3 don't match each other. So another example of one that wouldn't be like those would be like 3z to the 8th. That also wouldn't be a like term because now the exponent's not the same. So let's practice putting some like terms together. First of all, we just have to decide if the terms are like or not. So look at number 1. You have 4xy and negative 3xy. Look at only the variable part. The coefficient, that number in front, does not matter. It can be whatever it wants. As long as the variable part of the term is the same, then they're like terms. So yes, these are like because they're both xy's. Number 2, you have 2s squared and 5s. Looking at the variable parts, you have s squared and then just an s. Since they don't share exponents, they are not like terms. So I'll give you just a second. Look at number 3, decide yes or no if they are like terms or not. Remember, just look at the variable part. These are not like terms because their variables don't match. You have an a and a b, definitely not the same. So now 4 through 6, we're going to simplify if we can by putting things that are the same together. Because if I have things that are the same, like right here, 4xy and negative 3xy, I can combine them. It's just like taking a number and a number. I can add any number I want to any other number I want, like 2 plus 5. They're both numbers. I can add them up. The same thing happens with like terms. If they have the same variable parts, I can put them together and simplify it. And so instead of having two things that have an x, I can have just one thing. So if you look at this one, number 4, I have 4x plus x, and this x doesn't have a coefficient in front, but there's only one of them here. So what happens is that it is understood there is a 1 in front. We just don't write it because it's redundant. Clearly that is 1x. Okay, and then I have minus 3. Well, things that are the same are this 4x and this 1x. They are alike. They both have x's. Well, I can put all the x's together and combine them and only have one term with an x instead of 2. It simplifies my problem. So if I add these up, 4x plus 1x, that makes 5 x's. But this minus 3 is not a like term, so it just tacks on the end, comes along for the ride, and so that expression is now simplified. Now look at number 5. Find the things that are like terms and circle them like we did on number 4. So 13x squared is like this negative 10x squared, and I'm calling that negative 10x squared because the minus sign in front of it, it has to come along with it. We can't ignore the minus sign in front of that 10x squared. When I'm simplifying, I have to pay attention to the operation directly in front of the term I'm working with. So what I really have is 13x squared minus 10x squared. Well, 13 minus 10 is 3. That's still an x squared. All I did was figure out how many x squareds total I had. So it stays x squared, and then this plus 4 comes along for the ride. Now number 6 is different. Do you see any like terms on number 6? I don't see any like terms. What I see is an x squared and an x to the 4th. Different exponents makes not like terms. Since these are not alike, I cannot add them, so I just get to say that this one is simplified. You can't do anything else with it. Done. So easy. So now let's talk about something called the distributive property. And somehow my definition part is missing, and that's okay. We'll just write it up here. I'll make room. And we'll write our definition because you have a spot on your notes to write down the definition of the distributive property. So right here we will put the definition of distributive property. Fancy technical math definition. Okay? For the distributive property, the fancy technical definition looks like this. It says that if A, B, and C are real numbers, then A times the quantity B plus C is the same thing as AB, because A times B is AB, plus AC, because A times C is AC. Basically what that says, okay, fancy way of saying hippity-hoppity distributive property. Now we'll talk about the distributive property when we get to number 7. We will do the hippity-hoppity. This is the fancy math definition, and you should write it down so that, because you're going to see this kind of stuff, it's going to show up later, especially in geometry. If you've never seen it before, it might freak you out. So it's okay to know what the fancy technical math definition is. All this says is, if I have 3 numbers, an A, a B, and a C, and then they are written like this with the parentheses, I can take the number out in front and multiply it times everything inside by distributing it or sharing it with everything and simplify my expression. You always want to get rid of parentheses before you simplify, and that generally means you have to do distributive property. So here's how it works. First thing you do is 4 times A. Well, 4 times A makes 4A. Then you have to do 4 times 7. Well, 4 times 7 is 28. There was a plus sign in the middle, so it becomes 4A plus 28. The most common mistake that people make whenever they are doing distributive property is to forget to do this number times the end number. Make sure you distribute to everything. Now it asks us to evaluate if A is 5, so I have to plug this in. So I have 4 times 5 plus 28. Well, 4 times 5 is 20, and 20 plus 28 is 48, so there it is, evaluated. Now number 8 has a fraction in front. Don't panic, don't get nervous. Fractions are numbers too. It's all okay. We're going to multiply with the fraction, which is, since it says 1/4, it's really the same thing as dividing by 4, because if I'm trying to find a fourth of something, I'm just splitting it into 4 pieces. Well, that's division. So when I multiply 1/4 times 20 AC, well, 1/4 of 20, same thing as 20 divided by 4, happens to be 5. And the AC has to come along. Then I have to do 1/4 of 28, so I have to do 28 divided by 4. Well, 28 divided by 4 happens to be 7. There was a minus sign in the middle, so there is my simplified expression. This is easier to work with. That's why we simplify it. Now, 9 and 10 are a little more difficult. And 9 involves these fractions when you evaluate, and then, like I said, we shouldn't let them upset us. And then 10 involves some negatives, so I want to make sure we hit them both. So we're going to distribute first because we have to. So 8 times y becomes 8y. 8 times 2x becomes 16x. And then you have this plus 7y that goes down here. Well, I have to put like terms together now. I have some things that are the same. This 8y and this 7y can go together. Well, 8 plus 7 happens to be 15y plus 16x. And then now they've asked us to evaluate it. So we're going to plug in. X is 1/4. Y is negative 1/3. So I have 15 times negative 1/3 plus 16 times 1/4. Well, just like up here, these really are just division. 15 divided by negative 3, because I'm splitting 15 into thirds and it happens to be negative. 15 divided by 3 becomes negative 5. And then 16, 1/4 of that, so 16 divided by 4 happens to be 4. And when I simplify that, I get negative 1 is my answer. Now, number 10 has some negatives happening, so we want to address them, which is why I left it on here and made sure that this is one we're going to do. So this 18, there's no parentheses directly behind it, so we're just going to bring it down. There is a minus in front of this 1/2, so we're going to go ahead and put it, and then we're going to distribute. We're going to treat it like a negative. Negative 1/2 of 2x. Well, half of 2 is just 1, so that makes that negative 1x. And you can put the 1 if you want or leave it off. They mean the same thing. Now I have to do negative 1/2 of negative 4xy. This minus sign and this minus sign make a plus sign when you multiply them, because two negatives make a positive when you multiply. And half of 4 happens to be 2xy. So that part is simplified. But if you look at this next set of parentheses, all that's in front of them is a negative sign. That is like saying there is a negative 1 here. Just like here, the 1 is invisible. We don't write it, but that's what it is. So when I distribute, I have to do negative 1 times x, which becomes negative x. And negative 1 times y becomes negative y. Now I have to put like terms together. This negative 1x and this negative 1x can be combined. Well, if I do negative 1 minus 1, that becomes negative 2x. Then I'm going to put this negative y, and then I'm going to put this plus 2xy, because when we write expressions, we go in order, alphabetical, x, y, and then we put the two variables together, x, y. Double variables, triple variables, things with multiple variables will come at the end. Single variables just go in alphabetical order. That is your simplified expression for that. So now let's apply this with a couple of application problems. So we're going to write an expression and then we're going to simplify. So they tell us the length of a rectangle is 4x meters long and the width is 8x minus 4. First, they want an expression to represent the perimeter. Well, I have a rectangle here. Draw that rectangle on your paper so that you can label like I'm about to. Anytime you have a problem that involves a shape, draw the shape. And we're going to label. They tell us that the length is 4x. Then they tell us that the width is 8x minus 4. And they ask for an expression for the perimeter. Well, perimeter is just the distance around, so I have to add up all my sides. So I'm going to label all my sides. And there's a couple ways to do this. You can line them all out and do this plus this plus this plus this, combine like terms. Or you can just walk your way around the edges, adding up things that are the same. That's what I'm going to do. So I'm going to do 4x plus 8x, which happens to be 12x. 12x plus another 4x makes 16x. And 16x plus another 8x becomes 24x. Okay? Another way you could do that is you have 8x and 8x makes 16. 4 and 4 makes 8. 16 and 8 is going to make 24. So you have 24x. That's what happened when I added them up. And then I have to do my numbers. I have negative 4 and -4. Well, if I put two -4s together, I get a -8. So that is the expression for the perimeter. This is your answer for A. Now to answer part B, we're going to just evaluate it. It says evaluate if x is 3, so we're going to plug that in. So I'm going to do 24 times 3 minus 8. Well, 24 times 3 is 72, and 72 minus 8 happens to be 64. What that tells me is that if x equals 3, the perimeter of this rectangle is 64 meters. So that's the answer to part B. One more, and this is an important question. I know there is a question like this on your assignment tomorrow. I also know that there is a question like this that shows up on your test, and it is possible that there is a question like this on the TEKS check or benchmark that you will take towards the end of the year. It's kind of a big question. So they want the perimeter in terms of R, which means they want there to be an R in the answer. So we have to write an expression for the perimeter. Well, we want the distance around this square. All I know is that this is the radius of the circle. Well, if that's the radius of the circle, if I want the diameter, it becomes 2R because the diameter is 2 times the radius. Well, if the diameter of that one's 2R, then the diameter of this one is also 2R, which makes the length of this square 4R. And since I know it's a square, it says so right here, I know that every side is 4R. So if I want to find the perimeter, I just take one of the sides times 4 because there are 4 of them. Well, 4 times 4R makes 16R. There's the perimeter in terms of R. That's all they want, just an expression that contains the letter R. So that is simplifying expressions. We just take the things that are the same, combine them together, and then use that in some application problems, usually involving perimeter area, sometimes complementary and supplementary angles. But that is what that's our simplifying expressions lesson. So I will see you tomorrow, and we will practice this in class.